All right, so this is lesson 7.2. This is specifically talking about probability distributions for discrete random variables. Discrete random variables. So now that you guys know how to tell the difference between discrete versus continuous, we're focusing on the discrete today. All right, so for probability distribution, what a probability distribution does is it describes the long run behavior of a variable. All right, the long run behavior of a variable. All right, so for example, okay, let's say there's a city called Wolf City, and regulations prohibit no more than 5 dogs or cats per household. All right, so you can't have more than 5. And we're going to let X be our random variable, and X stands for the number of dogs or cats in a randomly selected household. All right, so this variable is discrete, right? We count how many cats, how many dogs. So now the question is, well, what are the possible values for X? Well, if X is the number of dogs or cats in this city that has a rule that you can't have more than 5, that means you can have either 5 or 4 or 3 or 2 or 1 or even 0, right? So these are your possible values for this random variable X. And let's say somebody took a survey and collected data from a very long, right, long run probability of how many households have these number of pets. So this right here, guys, this is a probability distribution for a discrete random variable. All right, so this is our main thing, and knowing how to read and create these charts. That's what you want to be able to do. All right, so to understand this, this means that in the long run, 26% of households have 0 pets. 31% of households have 1 cat or dog. 21% have 2, 13% have 3, et cetera, et cetera. Okay? And hopefully you notice that the sum of these probabilities should add up to 1, right? All of these should add up to 1. If you guys are ever asked to create your own, probability distribution, that's a quick check to make sure you got all those numbers right, is to add them up and make sure they add up to 1. All right, so for the most part, we're going to be showing these distributions as a table, but just know that you can also display this as like a histogram, like this. All right, so that's another way to display a probability distribution. But for this class, I think for the most part, we're just going to be using this table format. All right, so some specs about our discrete probability distribution. So first, it gives the probabilities associated with each possible X value. And 2, each probability, again, is the long run relative frequency. All right, it's the long run relative frequency of how many times each X value occurs. And usually displayed in a table, sometimes a histogram, or sometimes even a formula. We're actually never going to do that in this class, but just so you know, you can actually make it into a formula too. All right, so just remember, probabilities have to be between 0 and 1. And when you add them all up, they should equal to 1. All right, so let's try this. I think you guys will be really good at this. It's very intuitive. All right, so going back to Wolf City, this is our probability distribution. The question is, what is the probability that a randomly selected household in Wolf City has at most 2 pets? At most 2 pets. All right, so focus on this. At most 2 pets. What does that mean? Well, at most means that is the max. So that means I can either have 2 or 1 or 0. And since these events are mutually exclusive, I can just add up those probabilities. So then that will be 0.26 plus 0.31 plus 0.21, which is equal to 0.78. And that's your final answer. All right, and that's it. Questions on that? Okay, if not, then let's go on to The next part. So this one says less than 2 pets. Less than 2 pets. I'm going to have you guys try it. Same situation. Focus on the less than 2 pets. Think about what does this specifically mean? And go ahead and calculate your probability. I'm going to call on somebody, so get ready. Want to try this one out?
No, I don't know this one.
Well, perfect. Let's try it. So what does this mean, Clancy? Less than 2 pets.
I don't know.
So think about the X values. So which X values are less than 2?
Zero and one. I mean, or the P of X or the X?
The X, yeah. Which X values are less than 2?
0 and 1.
0 and 1, perfect. All right, so we're focused on just 0 and 1. Notice, not including 2. So good job. You did not include the 2 because less than 2 does not include 2. So Clancy, what do I do with those probabilities?
I don't know.
Well, that means I want the probability that a randomly selected household has 0 pets or 1 pet. So if it's or, what do I do with those probabilities?
Is there like a formula for it?
No. If I want this or that, right?
Oh, or are you gonna like subtract? Are you gonna subtract it?
Not subtract it. I don't want to subtract them. So if it's or, I want either this to happen or this to happen. And the probability of this happening is 26%. The probability of this happening is 31%. I'm okay with either of these two happening. So what should I do with these two probabilities? It's either add, subtract, multiply, or divide.
I don't really know. Maybe do you like add them then?
Yeah, you add them. Exactly.
Oh, okay. Okay.
Yeah, you just add them. So 0.26 plus 0.31, giving you 0.57. That's it.
Okay.
Okay? All right, any questions on that? All right, let's try one more. This one says, what is the probability that a randomly selected household in Wolf City has more than 1, but no more than 4? More than 1, but no more than 4. So kind of do what I did in the last example, right? Look at which X values satisfy what the problem is asking, and then add those probabilities. All right, so try this one out, and let's see if we get it. All right, and let's see, Karis, help me out with this one. Karis, what do you think?
I got 0.4.
Perfect, good. Okay, so tell me, Karis, how did you get 0.4?
I added 0.21 and 0.13 and 0.06.
Perfect. All right, so more than 1, but no more than 4. All right, so X is between 1, not including 1, but including 4, gives us 2, 3, and 4. So 2, 3, and 4, adding those probabilities, perfect, Karis, you get 0.4. Excellent job, guys. All right, that is lesson 2. Any questions?